Right, so in this video I'm going to have a look at the Leaving Certificate Higher Level Maths Paper 2 for 2015, and I'm going to have a look at questions 6 and 7. So part A of question 6 involves drawing a centroid of a triangle ABC, and we've got to show all construction lines. Where measurement is used, show all relevant measurements and calculations clearly. Now, I don't have the actual triangle from the question here. I'll just show you from here. I'm just going to have a look at this particular triangle here, and I'll show you how you actually draw a centroid. So what we've got to do first is draw what are called medians, and where the medians intersect, that's where the centroid of the triangle is. Now a median is the line segment that joins a vertex to the midpoint of the opposite side. So the centroid is the point of intersection of the median. So for example, if we take, let me see, we'll show the midpoint of CB here, for example. So the midpoint of CB would be this point here. Now I'll show you how to find that midpoint in a second, but the median then, well, this would be the midpoint of AC, and this would be the midpoint of AB. So if we were to create a median, then we would join this point, this vertex here, A, to this midpoint here. We would create another median then by joining this vertex here to the midpoint of its opposite side, and then we could do this one as well. Really you only have to do two here. The third one will go through that point of intersection anyway. So join this vertex to the midpoint of the opposite side. So the centroid is then this midpoint, this point here. It's not a midpoint, it's this point here where the three medians intersect. Now in order to find the midpoint of a line segment, you can just simply take your line segment, any line segment, and you draw an arc here from where, take A as the center. So get your compass, put the pointy bit of the compass here, and you can just draw an arc. You don't have to draw the entire circle here, you can just draw maybe from here around to here. Then do exactly the same here. Don't move the compass, and draw another arc from here to here. So what we're going to do is just join these 2 points of intersection here, and that will give you this point here, which is the midpoint of AB. So that's how we would go about finding these midpoints here. So you would just take, for example, this line segment here, do the procedure I've just shown you, draw an arc here, from here draw another arc, draw a line segment through the points of intersection, and where that line segment meets the line segment CB, that would be your midpoint. That would give you your midpoint here. So once you have your midpoint, then just join A to D. Okay, so that's really it. You do the same with the other two sides. Well, you really only have to do two sides, and where the two medians intersect, that's your centroid. You can do the third one if you like, just to be sure that you haven't done anything wrong with the other two. That's it really. That's your centroid. Now let's just go back to the question again. The second part of the question then was to prove that if three parallel lines cut off equal segments on the same transversal line, then they will cut off equal segments on any other transversal line. And this is what they've given you, this part here. So you have to do a diagram, you have to write down what you're given, write down what you need to prove, write down the construction, any construction you need to do, and then you need to do the proof. Now again, I'm not going to go through this. I've already done a video on this, and you can find it on my website, which is here. My website is just called malloymaths.com, www.malloymaths.com, and it's this is the home page here. So you've got home, you've got a junior certificate syllabus here, or junior certificate topics here. You've got leaving certificate topics down along here, and you've got a little bit more here. This is just extra stuff here. But you've also got here, you've got the junior cert syllabus, you've got the leaving certificate syllabus here, you've got my YouTube channel here where I keep all my videos, and I've got some junior certificate exam paper solutions here, and leaving certificate exam paper solutions here. Now what we want theorems. So I'm going to look at the leaving certificate, because we're doing a leaving certificate paper here. So just put the cursor over Leaving Certificate, go down to Geometry. By the way, the constructions that I've just done are there as well. If you go to constructions there, you'll find them in there. If we go to Geometry and click on Geometry, this page here will come up, and just I have a couple of videos there. Just scroll down, a few extra things there, and I have 3 videos here, 3 Leaving Certificate videos, 11, 12 and 13. So the one you need here is number 11. So you just click play. It's a YouTube video, and you just need to enlarge it, and that's it. So that's really the theorem that they're asking for here, and you can see the little diagram there, but you can enlarge it and have a look at that anyway. Okay, so that's really question 6. Now question 7 then is this one here. Now question 7 involves this part here. It's a flat machine part consisting of 2 circular ends attached by this plate here. Now it says that the sides of the plate HK and PQ, so HK and PQ are tangents to the circles. The larger circle has center A and it has a radius of 4r. The smaller circle has a radius of B and it has a radius of r. The length of HK, so the length from here to here, is 8 times r, and the length from A to B is 20 root 73. Okay, so the first thing we've got to do here is find what r is. We've got to work out what r is, and it gives us a hint here. It says draw BT, which is parallel to KH. So we've got to draw B up to here, which is parallel to HK. So let's just do that first. I'm not going to do this too accurately, but let's just see what we end up with here. So so I'll just draw a line. We're going to draw a line up along here. A little bit shaky, but you get the idea. It's this line along here, and this line here is parallel to this line here. So we've got a rectangle here, we've got this triangle here as well. So in other words, this would be 3r here, and this would be r along here. This is the distance r along there. So let me just do that here. So this would be r, this would be 3r here, making a total of 4r. Because remember, this is r here, so the opposite side of this rectangle will be r as well. Okay, so let's see if that helps. Well, what we can do here is use Pythagoras' theorem. We have a triangle here, and we know that this is 8r down along here. We know this is 3r along here, and we have 20 root 73 along here. So we could use Pythagoras' theorem here, because we would end up with an equation with just r in it as the only unknown, so we could work out what r is. So we could say 3r all squared plus 8r all squared will give us 20 root 73 all squared, and we'll work that out. So let's do that. Okay, so we have 3r all squared, and then we've got the 8r, and that's going to be all squared as well, and that's going to give me 20 root 73, and that's going to be all squared. So here we end up with 3 3s 9r squared. Here we end up with 64r squared, and when you work this out, you'll get 29,200. 29,200. So here then we'll have 9 plus 64. That's 73r squared, and that gives us 29,200. We divide across by 73, so that gives us 400 when you do that, and then we just square root both sides. That'll give us r is equal to 20 centimeters. So we now know that this distance here is 20. This is 8 times 20. And this here is 20, this is 3 times 20, this is 4 times 20, and so on. So we have all these dimensions here now for the next part of the question. So the next part of the question is find the area of the quadrilateral ABKH. ABKH. So we want ABKH. So we want to find this area here. So this really is the area of this triangle plus the area of this rectangle here. So that's what we're going to do. So we're going to find the area of this triangle, half the base times the height, the area of this rectangle here, length times width. That's all we're going to do. And the only unknowns we have here are or, and we've just worked out what or is. It's going to be 20. So we have all the dimensions of everything here that we need. So let's do all of that. So let's see, we have the area, let's say the area of the triangle first of all, ATB I think it was. Let me just double check that. ATB. Oh yeah, we're calling this part here T here. We call this point here, we're calling it T. So ATB is our triangle. So we'll work the area of that triangle out first, and that's just simply going to be half the base times the height. So really that's going to just be half times the base, that's going to be 3r times the height is going to be 8r. So that's going to be half times 3 times 20 times 8 times 8 times 20. So that's going to be half of 3 to 60 times 2 8 16, 160 here. So when you do that you get 4,800, and that's centimeters squared. We want now the area of the rectangle, so we're going to find the area of the rectangle now, and that's THKB. THKB. So that's just going to be length times the width. So that's going to be or times 8r. So that's just simply going to be, or was 20, and then we've got 8 times 20 here. So that's going to be 20 times 2 8 16, 160 here. So that's just going to give me 3,200 centimeters squared. So therefore the area then, the area of our quadrilateral, the quadrilateral was ABKH. That's just going to be 4,800 plus 3,200. So that gives me a total of 8,000 centimeters squared. And that's it really, that's that part of the question done. Now, find the angle HAP in degrees correct to 1 decimal place. HAP, let's have a look at that. What exactly was that? HAP. Well, that's HAP, so we want this angle here. Now, I'm not going to find that angle initially. What I'm going to do is find this angle here first. Because remember, I have a triangle here. I have this right angle triangle. I know that I know this side here. This is the adjacent to this angle. I know this side here, which is 8r, 8 times 20. This is 3 times 20. So if I find, this is the opposite, this is the adjacent. So if I find the tan of this angle, which I don't know, or the tan inverse of 8r over 3r, that will give me this angle here. So I'm looking at this triangle here, ATB, and I'm going to find the tan of this angle here, then find the tan inverse, and once I find the tan inverse of 8r over 3r, that will give me this angle here. I just need to double it then, that will give me this angle here, HAP. So that's the plan. So I'm going to do tan inverse of HAB, tan inverse of I'm going to do tan of HAB, which is 8r over 3r, and then I'm going to do tan inverse of 8r over 3r to give me the angle TAB. So let's just work through that. Okay, so let's see. I'm going to find the tan of the angle HAB. I know that that's going to be equal to 8r over 3r, the opposite over the adjacent. Really that's just 8 times 20 over 3 times 20, or in other words it's going to be 8, that's 160 over 60. That's another way of looking at it. But really here I've got the r's will cancel here, so it's really 8 over 3. So the tan of my angle is 8 over 3. So I need the angle, so that means the angle HAB is just going to be tan inverse 8 over 3. That's just going to give me 69.44. 69.44 degrees. Now I don't want that angle, I want to double that angle, so I actually want the angle HAP. So that's going to be twice 69.44. So that's going to give me an angle of 138.9 degrees to 1 decimal place. And that's it really. So let's move on to the next part. I think it's the last part of the question. Find the area of the machine part correct to the nearest centimeters squared. So the area of the machine part. Okay, so let me go back up again. This is the machine part here, this blue area here. So remember now, I already have this area here. I have the area of this quadrilateral we worked out as 8,000 centimeters squared, which means if I double it, I'll have this area here. This entire area here is going to be 16,000 centimeters squared. Double 8,000. So I have this area here, so really the only area I don't have would be this area here, this sector here of this circle, and this sector here. I don't have this sector either. So what I'm going to do is find the area of this sector, find the area of this sector, add them together, and then add them to double 8,000. That's the plan anyway. So I'm going to find the area of this sector here and this sector here. Okay, so let's move down again and work all this out. Okay, so let me just write down exactly what I'm going to do first of all. The area of the machine part then. Oops. The area of the machine part. So that's just going to be the area of the sector, the area of a sector HAP. Now this is the larger one, the larger sector. This is the large circle, the one on the left. So then we're going to double, remember, 8,000. Remember, we've already worked out the area of that quadrilateral, so we've got to double it. Then we're going to add also the area of sector for the small circle, and that was KBQ. This is the smaller circle. So that's what we're going to do. So let's work all this out. Now the area of a sector of a circle is going to be pi r squared times the angle we're talking about over 360 degrees. We're talking about degrees here, so we're going to use the degrees formula rather than the radians formula. We've got our twice 8,000, which is 16,000, and we've also got the area of another sector here. That's also going to be pi times r squared, and again we've got another angle. We'll actually call this theta 1, we'll call this radius 1, we'll call this theta 2 because it's a different angle, I think, and it's going to be over 360 degrees. There's going to be another radius. So let me just explain what these 1s and 2s are here. Well, we've got our large circle. The radius of that particular circle was 4r. So that's going to be 4 times, remember I'll put all this in a bracket here, it's going to be 4r, and remember r was 20, so it's going to be 4 times 20 squared. So it's going to be 80 squared really here. Our angle now, the angle for the larger circle that we're talking about. Now remember, we've worked out the smaller angle here, so if I just show you again here, we want this angle here. This is the angle we're talking about because we want to find the area of this sector here. We have already worked out this angle here. They got us to do that in the previous question. So all we got to do is take this angle away from 360 degrees, and that'll give us this angle here. Now, when we find the area of this sector here, remember this angle here will be exactly the same as this angle here. So I'm going to use the angle that we worked out previously to work out the area of this sector, and I'm going to take this angle here away from 360 degrees and to find this angle here to work out the area of this sector. Now, by the way, why is this angle the same as this angle? Well, remember this side here is parallel to this side here. This here is parallel to this side here. So this angle here is going to be the same as this angle here. So we've already worked out this angle here, so it's going to be the same as this angle here. Okay, so let me write all this down again. So we want the area of the larger part of the sector in the large circle, the circle on the left. Now what angle was that? Well, the angle we worked out was 138.9 degrees. We got to take that away from 360 degrees because remember we want the larger sector. So that's going to be 221.1 degrees. That's over 360. We're going to add 16,000 here again. Now we're going to work out pi. We're going to multiply that by the radius of the small circle, so that's 20. And we got to square that. That's 20. It's just going to be r squared, which is 20 squared. Now, theta then in this case was the angle that we worked out in the previous part, 138.9 degrees. So let's just write that down. That's 138.9 degrees here. That's over 360 degrees. And that's it. This is everything we need to work out the area of the machine part. So let's work all this out. Well, if you work all you can do all of this on your calculator. You can do it in a number of steps. You don't have to do it in one step. But when you work that out, you get 12348. 12348.55. We have our 16,000 here in the middle. And when you work all of this out, again, do it in 2 or 3 different steps, but you get 484.85. When you add all of these up here, you get 28833.55. That's centimeters squared. And remember, answer the question you were actually asked, and that was give it to the nearest centimeter squared. So that's going to be 288.33 centimeters squared to the nearest centimeter squared. Okay, and that's it for questions 6 and 7.